Alright, today we are cracking a code. Seriously, we're going to take equations that might look a little intimidating and turn them into simple, solvable puzzles. You ready to become an algebra detective? Let's get into it.
So I want you to think of every single equation like it's a perfectly balanced scale. You know, the old school kind. On one side you've got some stuff, and on the other you've got the exact same amount of stuff. Our entire job is to figure out what that one unknown piece is without ever tipping that scale. That's the whole game right there.
So here's how we're going to tackle this. First, we'll talk about our main mission. Then we're going to build out our toolbox with two super important tools. After that, we'll cover the one single rule that governs everything. And finally, we'll pack it all up into your brand new algebra kit.
Okay, so what is our actual mission here? It's simple. We need to get that unknown variable, the x or the y, all by itself on one side of our scale. And to do that, we have to make some moves, but the trick is making sure that scale stays perfectly level the entire time.
Okay, let's grab our first tool. This is the one you're going to reach for whenever you see your variable being multiplied by a number. Think something like 4w or 8y. This tool is specifically designed to neatly break them apart.
Now, the official name sounds a little fancy, the division property of equality. But forget the jargon. All it really means is this. If you divide one side of the scale by some number, you have to divide the other side by the exact same number. It's all about keeping things fair and balanced.
And you can see exactly how it works here. Look at the left side, with regular old numbers. It's kind of obvious, right? If 8 equals 8, then of course 8 divided by 4 is going to equal 8 divided by 4. You get 2 equals 2. The scale is still perfectly level. Now just look over to the right. We use the exact same logic in algebra. To get that w all by itself, we divide the 4w by 4. And to keep the scale happy, we got to do the same thing to the 8. And boom, just like that, we see that w equals 2.
Let's try it with a new one. 8y equals 56. Okay, step 1. What's our goal? Get y by itself. Since y is being multiplied by 8, we do the opposite. We divide by 8. And what's the most important part? You know it. We do it to both sides. So, what's that going to leave us with?
And there it is, 7. We've just found our missing piece. Y equals 7. But are we 100% sure?
This is my favorite part, the proof. We just plug our answer, 7, right back into the original equation. Does 8 times 7 equal 56? Yes, it absolutely does. 56 equals 56. The scale is balanced. We know for sure our solution is correct.
All right, let's keep building here. What if your variable isn't being multiplied? What if it's being divided, like say x over 4? Well, that's a different kind of problem, so we're going to need a different kind of tool.
So, meet the multiplication property of equality. It's basically the mirror image of our first tool. This one says that if you multiply one side of the scale by a number, well, you've got to multiply the other side by that very same number to keep everything in balance.
So let's say our puzzle looks like this. X divided by 4 equals 8. The goal is exactly the same. Get x all alone. To cancel out or undo that division by 4, we're going to use its opposite, multiplication. Okay, here we go. New problem, same exact process. N divided by 3 equals 12. Our mission? Isolate n. To undo that division by 3, what do? We multiply by 3. And where do we do it? You got it, to both sides. So we get 3 times n over 3 equals 3 times 12.
Which gives us our answer, n equals 36.
Okay, moment of truth. Let's check our work. We plug 36 back in for n. Is 36 divided by 3 equal to 12? Yep, it is. 12 equals 12. The scale is perfectly balanced. Our answer is solid.
And this, right here, this is the aha moment. This is where it all clicks together. See, these two tools aren't just random tricks. They're perfect partners. They're what we call inverse operations. All that means is they're literally designed to undo each other. If you see multiplication, you use division. If you see division, you use multiplication. It's that simple. It's a beautiful little system.
So we have our two main tools, but both of them operate under one single unbreakable principle. This is it. This is the golden rule of algebra.
And here it is. This is probably the most important thing you'll learn. To keep the scale balanced, what you do to one side of an equation, you must do to the other. Always. Whether you're multiplying, dividing, adding, whatever, you always do it to both sides. No exceptions.
Well, okay, almost no exceptions. Here's the one thing you absolutely can never, ever do. Divide by 0. It just doesn't work. It mathematically breaks everything. And you also want to avoid multiplying by 0. Because while it technically keeps the equation balanced, it just wipes out your variable and turns the whole thing into 0 equals 0. It kind of breaks the game.
And just like that, you've done it. You have officially stocked up your brand new algebra toolbox with some seriously powerful and essential gear. You're geared up and ready for the next puzzle that comes your way.
So let's do a quick check of what's in our new toolbox. First, your goal is always to get that variable alone. Your mental picture, that perfectly balanced scale. Your golden rule, the one you'll never forget, whatever you do to one side, you do to the other. You've got your two main tools, division to undo multiplication and multiplication to undo division. And finally, your secret weapon, the proof. Always check your answer so you know you've cracked the code.
You know, this is really just the beginning. The logic you learned today, this idea of balancing operations to find something you don't know, that is the foundation for solving all kinds of puzzles, way beyond a math class. We're talking everything from figuring out a budget to understanding a science experiment. So the only real question left is, what are you going to solve next?